Okay, on to page 20 in the classwork. All right, a couple more fill in the blank proofs. We're going to look at this given. One thing I didn't point out on 19, you see how there are two lines here, two different things that they use? Sometimes you'll see it where all the given is written at once, and sometimes you'll see it broken up where they need it. Either is appropriate as long as it's all information there, and understand that when they do give you something, you will be using it. That's why it's a given. You're going to need it for something. Okay? Here we have US is parallel to RT. So I always mark these parallels. It looks like they try to do it right here. Little arrow. Okay? And then RS bisects UT. So RS bisects UT. So that means we have this is the same and this is the same. Now, interestingly enough, when I first did this problem, what I did was I looked right here and I saw vertical angles, and I thought I was going to use that. But actually, the way the proof is laid out, they use alternate interior angles twice. They use U, and I'm going to put two markings here with T, and then they put R with S. So if you look, you have all of the angles the same. The way this proof is laid out, they're going to use angle, angle, side from just alternate interior angles. They won't use the vertical angles, but that is an acceptable method to go about using this proof. So I'm going to go through what they have on the page. US is parallel to RT, and that's given. Okay, and what we did was we had our angles. Angle U is congruent to angle T, and angle S is congruent to angle R. And I'm going to abbreviate so I don't go off the page here. Alternate interior angles are congruent. Okay? And then they come back and they give us the bisector. SR bisects UT, and that's the other piece of the given. And what we put together that we need is a side. So we know TM is congruent to UM. And our reasoning is a bisector divides a segment into two congruent parts. Did I get all that? Almost. Missed by a couple of letters. Okay. Now at the end when we look at it, now either way we look at it, the way we did it, angle, angle, side, angle, angle, side, and that is our conclusion. Okay. Now I'm going to move on to number 6. Okay. And our given is that PQ is perpendicular to QM. So here's PQ, here's QM, and they put the right angle in there. I just darkened it, that was there. RS is perpendicular to SM, so we have another right angle. And we know M is the midpoint of PR. So PM and RM are the same. If we look again, we have vertical angles. Now, a hint that Miss Ebers taught me, a shout out to her here, if you number these angles, they are easier to use in the proof. I know in this proof they actually use the angle names, but QMP and SMP, sometimes you're better off just having them numbered, and it's easier to read that way. Okay, so let's get into the proof. They have our perpendicular lines are given, PQ perpendicular to QM, RS perpendicular to SM. Now our next reason is perpendicular lines form right angles. So what we have to do is we have to state that angle Q and angle S, angle Q and angle S are right angles. Okay? Perpendicular lines form right angles. Now what do we know about all right angles? They are congruent. So angle S is congruent to angle Q. Okay, right angles are congruent. Now they came back, the other piece of the given, M is the midpoint of PR. So I'm guessing that if they told us that's the midpoint, we need that side. We're going to go to PM is congruent to RM, and our reason is A, midpoint divides a segment into two congruent segments. Again, missed by a couple of letters. There it is. Two congruent segments. Now they gave us the angles QMP, so what I put as angle 2, and RMS, what I put as angle 1. Okay, those are vertical angles, so we say vertical angles are congruent. And then our triangles are congruent because we have angle, angle, side, angle, angle, side. There we go. Okay, that's page 20. Coming back at you in a few minutes with page 21.